Began last year during a school space workshop where we had opportunity to observe the sun through solar telescopes and learn about space weather. This workshop showed us that in fact how much of our lives we entrust to the sun, which we know so little about. After some research, we realized that some estimates could be provided.
Solar storms are caused by the sun's magnetic field. When the sun's equator rotates faster than its poles, it creates stress in its magnetic field, which causes it to release massive amounts of energy in the form of solar storms.
This can cause damage to satellites, communication systems, and even the power grids on Earth. Imagine if our GPS network was down for hours, delivery systems, emergency response, and personal navigation will be impacted.
The sun follows an 11-year cycle, switching between solar minimum and solar maximum. We are approaching the solar maximum in 2025, when solar storms are most frequent and intense. This means a higher risk of disruptions to GPS systems, power grids, and communications. Experts predict stronger storms, so we need to be prepared.
This made us wonder, what if we could predict these solar storms like weather forecasting for space? We thought that a system like this could reduce their impact on critical infrastructure.
While systems exist to monitor solar activity, they often lack the speed, automation, and accuracy needed to prevent significant consequences. We realized that there is a gap in how solar flares are detected and predicted.
This gap motivated us to develop a faster and more accurate system using artificial intelligence. We decided to use conventional neural networks, CNNs, a technology well suited for image processing, to analyze solar images and identify patterns in solar activity that indicate an impending flare.
We have developed two CNN models. The first analyzes continuum images to observe surface activity on the sun, while the second uses magnetogram data to study magnetic fields. These models detect patterns that are invisible to the human eye, and we train them with thousands of images to make them as accurate as possible.
But we didn't stop there. To increase the sensitivity of the system, we have integrated the KP index, a measure of geomagnetic activity, into our models. This addition helps assess the severity and potential impact of solar flares on Earth's infrastructure.
The combination of our CNN models along with the KP index algorithms creates a powerful, unique system. The CNN models process real-time solar data to detect patterns in solar activity that signal a potential flare, while the KP index algorithms assess the potential impact of these flares on Earth. In this way, we have a fast, accurate, and automated solution.
For example, a satellite operator will receive a detailed alert telling them when the flare might hit and whether they need to take immediate action, like shutting down sensitive systems to protect their satellite.
Our system equips critical infrastructure operators with tools to mitigate the effects of solar flare. From communications to navigation to power grids, our real-time alerts reduce the risks posed by the solar storms.
What started a curiosity about space weather has evolved into a solution with the potential to increase global resilience to solar storms. By predicting solar flares in advance, we can protect our technology-dependent world and ensure security and sustainability for future generations.